sides, then I'm going to use the alternative form. But these all just come from rearranging the standard form. That's all I'm saying. So you can start with either one and get there. All right, so given 3 sides, and we're going to have standard labeling of the triangle. I'm not drawing it to scale, I'm just drawing a triangle. We have little a is 9, little b is 12, and little c is 14. So find the 3 angles. So your end answer box needs to have the measure of A, B, and C in it. And so start with either one you want. But I want to use it as a pattern. I'm going to look at the cosine of A is, well, here is the alternative form when we're trying to find the angle. The b squared and the c squared are the 2 sides that include the angle. And that formula starts with those. The minus a squared is the side opposite angle A. So if I am trying to find the measure of angle A, the side opposite it is 9. The 2 including sides are 12 and 14. It's a pattern. And if you can remember the pattern, it's just helpful, even though you have the formula. And so what goes here are the 2 sides that include the angle you're trying to find, squared, and I don't care which one comes first or second. And then the side squared that you subtract is the side opposite the angle you're trying to find, and that is 9. So we're going to subtract 9. And the 2BC is this product of the 2 sides that include the angle doubled. The 2BC is the product of the 2 sides that included the angle doubled. And so the sides that include the angle we're trying to find are the 12 and the 14. And so to find the measure of angle A, we are just going to do the inverse cosine of those. And so I would do this on my calculator in just one step, because then I can go back and edit it to find another angle. So I'm going to attempt to model that then. And so I want the angles in degrees, so make sure that your angle is in degree mode. And then I am going to do inverse cosine. And I want the numerator to be in parentheses so I get that value before you divide by the denominator. So I'm going to put an extra parenthesis. And then I had 12 squared plus 14 and then squared minus 9 squared, and a right parenthesis, so I've got the numerator in its own set of parentheses. Then divided by parentheses around the denominator, and it's 2 times 12 times 14. 2 times 12 times 14. Now, I have to remember I have one parenthesis for the denominator and another parenthesis so that I get the inverse cosine of that quotient. I'm just saying so you can do it all at once. And then I'm going to show how you can store this. So you should be getting the 39.57121946. So that is your measure of angle A. And I have it to 3 decimals on my paper. I want to change that to 3, so it's 0.571. All right. Now, there is a store button. And so because when you find 2 angles, you need to add them up and subtract from 180. I'm lazy. I don't want to retype all these digits. I can, but if I can remember how to use a storage button and not have to type them all in again, that would be nice. And so there's a store feature and there's a recall. Right now, I want to store it. And so when I hit stow, I have choices. And I'm just going to, it's angle A, so I'm going to store it in angle A. If I wanted to change it, I can with the arrow, but I want to store it in angle A, and then I'm just going to hit enter. And now that is the value of A. And I can write that angle down as 39.571. All right, and then I can just hit clear. If I go to second recall, when it's on A, there is the value stored. Notice I don't have anything in any of the other letters because at this point I haven't stored them. And to get out of that and get back home to calculating, you just hit clear and it's stored. All right, so let's go back now and look at finding another angle. Sometimes people want to change it at this point and go to law of sines. I discourage that because there are some cases, if right now when you switch to law of sines, if you switch to law of sines, you actually are in the possible ambiguous case because the next thing you are forced to do makes you work with side-side angle. And so there's a possibility that you will get the wrong triangle. There's only one correct triangle for this, but if you switch to law of sines right now and you happen to hit that ambiguous case, which it will be the side-side angle, that is what you're going to be working with. You could get the wrong triangle. To avoid that, stay with law of cosines. And it isn't hard if you use some recall on your calculator. So, setting up cosine of B. Right here, squared, I want the sum of the 2 sides that include that angle. Right here, I want the sum of the 2 sides that include that angle. I'm trying to help you to remember it so it's not going back through 6 formulas and having to very carefully pick them out. It is the 2 sides that include that angle. So I have 14 squared plus 9 squared. And right now, I might as well change the denominator to 2 times 14 times 9 because it's always twice the product of those included sides that are in the denominator. And then here it is minus little b, the side opposite this angle. It is minus the side opposite angle B, which we're trying to find, squared. So in this case, that is your 12. And then to find the measure of angle B, oops, you need the inverse cosine. And over here, I had excuse me. So for this one, I want to just go back to the calculator. And I'm going to arrow up, and it's got, when I arrow up, it has where I have that inverse cosine. And now I just need to change some things up. Did I put the 9 squared first? On your notes, did I have 9 squared first? 12 squared and then plus 9 squared? or 14, okay, 14 squared and then plus 9 squared. All right, that's all I wanted. So it's the 14 squared. And so when you're on top of this and you type another, it will change it out. But then when I go to here, I need this to be 9 squared. That is going to be, I want to delete one of those, so I can delete the 1. And then I need to change the 4 to 9, but now that I'm on top of it, I can just press 9, and it's squared. And minus, here I need to override, and I need it minus 12, so I can make this a 1, but I don't want to change out the squared, so that's where I need to insert a 2. So I need to switch from a 1-digit to a 2-digit. And so I can only override 1 digit. The next is I want to insert 2, and it'll put it in front of the cursor. These are just some handy things to know about your calculator. And then I've got that whole numerator in parentheses, and I've changed it out. And when you get comfortable with it, it's pretty quick. And then in the denominator, I need the 2 times the 14 times the 9. So I've got the 12 there, or the 14, and I want to change it to a 9, so I need to delete one of those. And then I'm on the 4, replace it with 9. And then I should have it. And there is your measure for B. But right now, I want to store that, and I want to store it in B. So I want to take that answer and store, but I want it, A is already there. I don't want to change A. I want to store it in B. And there it is. Now it is stored in B. And you can write it to your paper. So on your paper, I always write out a few extras in case I end up using it again, so I don't have to go back to calculate it. But the last thing I want to find is the measure of angle C, and I could easily go back and change up and just do law of cosines for angle C, but most people don't do that. They are going to take the answers that we had for A and B, add them together, and subtract from 180, and I need degrees on those. But now, because we stored those in our calculators, I can go to the calculator and I don't have to type in all those. Not that that's horrible, but it's just a nice thing to learn about calculator. And all your scientific calculators will have an ability to store. I can't show it on every calculator. You can Google and get a YouTube video for your calculator model. How do I store values and recall them and clear them and change them? And you can figure that out. But for this, I'm just going to clear this. And now I can go 180 minus, and then I want the sum of them, and I need to recall. So it's a second function of store. Second recall, A plus second recall. I need to arrow over to pick up B, and yes, that's what I want. And parenthesis. And there I have the measure of angle C. And I didn't have to do a lot of retyping. And I'm happy to help you with that if you are interested in being able to do that, and it's a little too quick to follow. And then I want the answer key. I actually think that's easy to do. I like this. So to 3 decimal places, the answer box. Don't forget degrees. All right. The next thing says, knowing the cosine of an angle, you can determine whether it's acute or obtuse. I didn't have you actually calculate these out. The cosine of this angle is this value. If I evaluate this and then substitute it in, if it is positive, it's a quadrant 1 angle because cosine is positive in quadrant 1. Cosine of theta is positive in quadrant 1. If this comes out negative, then you know it's a quadrant 2 obtuse angle. And that's all that this is saying. Because all of our angles were under 90 degrees, each one of these expressions ended up positive if we would have calculated it. Just a little something there. When to use law of sines? When you have angle, side, angle, angle, side, and when you have side, side, angle, but this is where you have a possible ambiguous case and get two triangles. When you use law of cosines, side, 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 or side, angle, side, when you have the two sides that include the given angle. Back to geometry. And we just saw an example where you're given side, side, side. All right, backside. So, standard labeling of a triangle. And again, I don't worry about doing it to scale. So A is 75 degrees, little b is 12, and little c is 10. And so this is side, angle, side. You actually don't have enough information to do law of sines. You are forced into law of cosines. And so I would find A, and you're using the formulas, the standard form. And it is a squared is then going to be the two sides that include angle A, which are your b squared plus your c squared, minus twice their product times the cosine of the included angle. It's a pattern. So when I want to find this side, it is a squared. And then the b and the c are the two sides that include that angle. So it's 12 squared plus 10 squared, and then minus twice their product. And then we're trying to find the measure of angle, or no, we know the measure of angle A, sorry. We know the measure of angle A is 75. Don't forget the degree symbol. Now, most people do this all kind of in pieces. You get 144 plus 100 is 244. And 120 doubled is minus 240. This is where some people will go wrong, and they will subtract these two. And that is absolutely wrong. This is absolutely not 244 minus 244 cosine 75 degrees. It's the wrong order of operations. You're subtracting when there's multiplication in there. Multiplication comes before subtraction. This must be calculated before you subtract. And I see people doing that. And that happens when you don't check your homework, or you're just copying homework and you don't actually get that ironed out in your homework. But you don't really have to combine them right there, because it is just going to be the positive square root because it's a length. And so put that into your calculator. Oh, I don't know why I wrote a 50. I have no idea. That's not supposed to be a 50. It's supposed to be a 40. And the other thing is practice your calculator skills. Don't be lazy and just write down answers from a worked out solution. Make sure you know how to do the calculations. So we have the square root. Oops, clear. The square root function. And then 244 minus 240, 40, cosine of 75. The calculator knows to do the product before the subtraction. Did I get 240 or 1? Did it get the 2? Yeah, okay. Oh, that's not what I wanted to have happen. And that is your side length for A. I would definitely write it out to a few extra decimal places. But note that you can store it in case you want to use it again. And since it's little a, and I already know angle A, I could choose to store, and A is underlined, and hit enter. And now it has overwritten your old A, and that's in there as that side length. So if I want to use it again, it's in my calculator. So back to notes. And now you can find an angle using law of cosines again. You can switch to law of sines, but I just as soon stick with law of cosines. And because I don't find it hard. So say that I want to find the measure of angle B next. The cosine of B is, what is it? You take the two sides that include it, and you square them. And in the bottom, it is twice the product of those. And at the end, you subtract the side squared, that's the side opposite of it squared. And then the measure of angle B is going to be the inverse cosine of that. And if you want to start by writing that right away, that saves you a whole line. So in my calculator, I'm going to clear. I'm going to do the inverse cosine. And I want the numerator in its own set of parentheses. And I have 10 squared plus, now I can do my recall. I have stored the value of A in A. So I can second recall, and I can choose A. It's going to be a long set of digits there, and then I have to square it. And then I have minus 12 squared, right parenthesis to end the numerator, divided by, and then it is twice the product, 2 times 10, times, and then the recalled value again. And I have it in A. So second recall, there it is. And then a parenthesis to get the denominator in parentheses and a parenthesis for the inverse cosine. And there it is. There is my cosine. And then I want to store that is measure in angle B. I want to store that in B because I'm going to have to find that third angle. So I'm going to store that, be careful to go over to B and hit enter. And now that's in B. So I can clear, go back to the notes. And I that this is 59.25662 degrees. So I have two angles, and I can find the measure of angle C by taking 180 degrees minus 75 degrees plus. Don't forget the degree symbols. But because I stored it in the calculator, that's angle B. I have a little less typing to do. So 180 minus the sum of 75 plus, it's the measure of angle B that I want. So second recall, arrow over B, and right parenthesis. And there I've got the measure of angle C. And since that's the last thing I'm going to find, I can just put it in there like that. And then I want my answer box. And the first thing we found is little a. And there were no units, so we don't need units. Then we found the measure of angle B. Don't forget the degree symbol. And then the measure of angle C. Just when you have side, 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 or side, angle, side, just stick with law of cosines. Don't switch to law of sines. Don't put yourself in jeopardy of hitting that ambiguous case. All right, and then we have a word problem, and it takes reading through it 3, 4, 5 times to start piecing together. We gave you a diagram, and so to help out with it, in a softball game, a batter hits the ball to left field. And part of that is you might have to look up what's to left field. So this is home plate. And left field, they're saying there. So it's a line hit, I guess. And so the left fielder out here then throws the ball to second, which is be here. So this is home, first, second. And the distance from the left fielder to home plate is 160. The distance between home plate and second is 85 feet. And so the bases, we have a square so that when you draw from home to second, this is going to be a 45-degree angle. So in all of that, they're giving you information so you can set up a triangle. This is 160. This is 45 degrees. This is 85 feet. Oh, we have side angle, side. a place where we can use law of cosines. How far did the left fielder throw the ball? The left fielder threw it from outer field to second base. So that is this. And that is where I don't need the formula if I know the pattern. I'm trying to find the length of the side that is opposite the angle that's given. And this is a side angle side, which is law of cosines. The two sides that include the angle are what I need to square here, not degrees. And it's minus twice their product, not squared, just their product individually, times the cosine of the included angle. You can literally just take the square root of that and get D and put it in just like that, if you want to. Most people like to simplify it a little bit. This part right here comes out to 32,825. And then 2 times 160 times 85 is 27,200. You could actually get an exact answer by letting cosine of 45 degrees be root 2 over 2 and leave it at that. But then the distance is the square root of that. Again, do not subtract those two, because the order of operation is the 27,200 must be times the cosine of 45 first. And then just evaluate. So clear, and we need the square root. And it's in degrees, so make sure your calculator's in degrees, because you never know who used it last. Oops, but I missed a 5. And that's one thing that you do kind of have to be careful with, is double checking your values, because there's nothing I can really do for you if you mistype it to get the answer. And there it is, 116.583 feet. And that's it.